Assalamualaikum and very good day. So I will share with you a slide or lecture on energy balance. So what is an energy balance? An energy balance is a consideration of the energy changes and energy flow in a chemical process in terms of energy input, energy output, consumption, or generation in a process or stage. Okay. The first law of thermodynamics or law of conservation of energy states that the internal energy of a system has to be equal to the work that is being done on the system plus or minus the heat that flows in or out of the system and any other work that is done on the system. As we know that the first law of energy can neither be destroyed or created. It can only be changed from to another. Okay, so if you notice, this energy balance equation basically same as mass balance equation. Mass balance, we have mass mass input minus output sama dengan accumulation tambah dengan generation. But for energy balance, there is no generation or consumption. Why? Because ini kena faham lah, because energy balance energy equation ataupun first law of thermodynamics mention that the energy can neither be destroyed or not destroyed, so there is no energy generation or consumption. In the simple way, we can define energy balance as the amount of energy gained by the system must be equal to the amount of energy lost by its surrounding. Okay. Remember, we have a system where there is a boundary and then there is mass in ataupun heat in ataupun enthalpy in and out. And in energy balance, there is other form of energy and energy transfer to the system or to the surrounding. Okay. Next, why do we need to study energy balance? Because we want to calculate or to determine the amount of heat required for a process ataupun system. Maybe we want to know what is the pattern of energy usage in operation. What are the pump power is required for the system, and then we want to know the process design to determine energy requirement of a process, and so on and so forth. Okay. Forms of energy. There are three forms of energy ataupun three components of total energy of a system. There are kinetic energy, EK, and then potential energy, EP, and internal energy, U. So what is kinetic energy? Kinetic energy is due to translational motion of the system as a whole relative to same frame of reference. Okay. Ataupun kinetic energy known as a energy of motion. Kalau ada pergerakan, then we know the EK must be any value. There is not zero, bukan kosong ya. But if there is no change in motion ataupun there is no motion, so EK equal 0. And then EP, what is EP? EP is energy due to the position of the system in a potential field, such as a gravitational or electromagnetic field. EP ataupun dikenali sebagai energy caused by a change in elevation. So, kalau there is a change in elevation, EP must not be 0. Then internal energy. all energy processed by a system other than kinetic or potential energy. Other than that, both of EK and EP, so that one is internal energy. Internal energy is defined or due to translation, rotation, vibration, and electromagnetic interaction of the molecules, atom, and subatomic particles within the system. In a simple way, internal energy is described as other energy and due to molecular interaction. Okay, let's say that if there is a phase change ni maksudnya from liquid to water, from liquid to solid to liquid, ataupun solid to gas to solid, ataupun gas to liquid. So there is a phase change. It means that there is internal energy. Okay. So other than internal three forms of energy, there are other two types of energy under transfer of energy. Okay, in a closed system, there is no mass. No mass is transferred across the system boundary while the process is taking place. Energy may be transferred between such a system and its surrounding in two ways, as heat or work. So heat or work are so defined as energy. Okay, so for heat, energy that flows as a result of temperature difference. Kalau kita ada delta T, so between system and its surrounding, maksudnya dia ada heat lah. The direction of flow is always from a higher temperature to a low one. Daripada it transferred from higher temperature to a lower temperature area. Heat is defined as positive. Ini kena tahu ya, bila positif atau negatif, when it's transferred to the system from the surrounding. Heat is defined as negative when it's transferred from the system to the surrounding. Faham Okay, kena tahu bila negatif dan bila positif. And then work. Work is defined as energy that flows in response to any driving force ada a temperature different. Selain daripada temperature different, we can say that is a work energy, transfer of energy that you may consider is work, not heat. Kalau the temperature different, that is heat. Okay. For example, force, torque, or a voltage. Okay. So this can be piston, pump, or turbine. Kan? Kalau ada pergerakan dalam piston ada ataupun dalam pump, so because of driving force, so there is a work happen. Okay, ataupun and then work is defined as positive when it is done by the system on the surrounding. Kalau negative, when it is done by the surrounding on the system. So nanti you kena tahulah bila dia negatif dan positif. Okay. First law of thermodynamics, the general form of first law of thermodynamics, inlet energy plus heat minus outlet energy minus work sama dengan equals accumulation. Inlet energy and outlet energy is summation ataupun total of all energy such as potential, kinetic, and internal energy. So inlet and outlet energy are the three types of form of energy. It can be internal, potential, or kinetic. Okay, so each of the three different kind of energy, they have their own equation. For example, kinetic energy, EK equal half mv or mu, velocity, power of 2. And then for kinetic, when it is related to weight, so we know that we must put E dot or m dot same m dot is a mass flow rate. Okay, so for EP equal mgz, z is a change in elevation ataupun change in height. Okay, if there is fluid end-type system with a mass flow rate and of elevation z relative to potential energy waveform plane, so you must have to use the equation is this one. Okay, for closed system, in this lecture or course, I only consider closed system, but there is a open system, non-reactive system, and reactive system under energy balance. So you will learn further in energy balance course. Okay, second year I think. Okay, so for closed system, there is no mass transferred across the system boundaries while the process is taking place. So the equation is this one, and this is the final equation. Kita masukkan balik semua, kita rearrange. If become delta U plus delta EK plus delta EP equals Q minus W. Okay, kena ingatlah equation ni, equation delta ni ingat ya, please ingat, penting. Okay, so what is system? So for this part, I will continue later, but I would like to share with you on, I would like to explain further on this part, transfer of energy. Okay, positive and negative. When we should when the heat is positive or negative. So what are the things that we should know? Okay, for example, we have an vector. Let's say this is vector. The reaction takes place in the vector is at 700 degrees C, and the temperature, surrounding temperature is 25 degrees C. Okay, so what will happen is that the heat will flow from the system to the surrounding, since there is temperature difference, betul? And then heat will flow from higher temperature to the lower temperature, to the low temperature, kan? So betul, ingat yang ini ya. So in this case, heat ataupun Q is negative. Why? Because it is transferred from the system to the surrounding. So our Q will be negative. Okay, faham yang ini saya explain, kena faham. Okay, so that's it for this for first part of energy balance. Okay, thank you. Assalamualaikum.